Hello, my name is Garrett Livesey. I'm a member of the Good Shepherd Senior Design 2 team. The goal of our project was to provide an alternative method to herd cattle and sheep and other livestock. We wanted to give alternatives to using shepherding dogs, which are very expensive. They can cost up to $2,000 and up to $1,000 a year to feed, in a more humane way to herd cattle than using cattle prods, which can cause physical harm and stress to the animals. We did this by designing this ultrasonic frequency generator device that is capable of producing 2 ultrasonic frequencies that are outside of the range of human hearing, but within the range of animals. We decided to do 2 frequencies because we wanted to make sure that the sound emitted was completely unique and would not be mistaken for any other sound of nature, so that animals could pick it out of the crowd. Our device is made out of both COTS parts and parts designed and manufactured by the team. The ultrasonic frequency generators, speakers, switch and cabling, and fasteners are all COTS parts, commercial off the shelf. And the housing and the aluminum mounting bar was designed and manufactured by our team in the makerspace. Throughout Senior Design 2, I was able to contribute to the test plans. I designed the method of testing for our field testing. We tested 10 different species by having the device set at different frequency settings, either 7 and 8, which is 27,200 hertz and 30,400 hertz, or 9 and 10, which is 33,600 hertz or 36,800 hertz. We would test at different ranges and see what differences there were for the animals. The other test plan that I wrote was for the power consumption. We wanted to see how long the battery that we chose would last in the field, both while it is mounted to an ATV and while it is not being continuously charged. We found through our test of the battery that the device was able to last for 48 consecutive hours while not being continuously recharged by the alternator, and that the device was being continuously charged by an alternator faster than it was being consumed. So while on an ATV, there's no risk of killing the battery. I also wrote the test plan for the water test. The water test was to ensure that the device could operate in all areas of operation and all weather types, so that there's no water to be able to get into the device. We wanted to meet the IPX6 rating, which involves having water being jetted into the housing from 360 degrees in a rotating fixture. We weren't able to send the device to an IP facility for testing, but I wrote a test plan that mimicked it as closely as possible and was able to pass that test, and we therefore believe that if we sent it out to a facility, it would be able to pass that as well. Thank you.
My name is Shay. I am part of the Good Shepherd team. My main role in this project was the technician and designer of the housing of the device. As far as fabrication for the device, we chose using polycarbonate filament and 3D printing a main prototype. For future iterations of the device, if we do decide to mass manufacture the device itself, we will opt instead for using injection molding, as it is much faster and it will provide far greater housing structure, because with 3D printing it prints in layers. So with drop testing, when we did the drop testing, it cracked at the layers, so with the injection molding that won't be a problem. And as far as changes during the senior design process, we noticed that during the drop test we had problems with the thickness of the flanges that were attached to the metal bar itself, in which it snapped off during the drop test. So to fix that, we doubled the thickness of the flanges itself and then added a bigger fillet so that it'll have a much stronger adhesion to the device itself. And then as far as an oversight during Senior 1, during the initial design of the device itself, I added a hole in the bottom so that we could pull the wires through there. And then for the field testing, Main animals that we tested on were cows, chickens, goats, horses, deers, dogs, and cats. The strongest result that we got from all the animals was from the dogs and the cats, and they had the strongest repulsive response. So for future iterations, we hope to test on coyotes to better understand if it'll be a better predator deterrent. And then in future iterations, we hope to use a AI camera to analyze and figure out which animal is getting close to the device so that it can differentiate between the two, and say if it's a coyote, it'll switch it to one frequency, and then if it's a cow, then it'll switch it to a different one.
Hello, my name is Dawson Field. I was in charge of assembly and IP water testing for this device. So I was in charge of making sure that all the wiring that we acquired was going to remain internal of the device and be non-adjustable to the customer once they got the device. So everything is sealed and put away and basically locked away to the customer, and they can't adjust any of the settings internal to the device. I was also in charge of the water testing, so I had to make sure that no water was able to go inside the device for any scenario that the customer is going to be using it out in the field. So I had one test where it actually failed. I didn't put enough sealant in there, so water seeped into the mounting holes, as you can see here. And so when I applied a secondary layer of sealant, the front panel faces are sealed on there, and no water or any moisture is able to seep in through any of the cracks or holes in the device. So I was also in charge of creating the test plan for the drop testing that we were going to be doing. Basically, we were going to be dropping this device from about 4 feet high, which is an average about shoulder height for most humans. So in case someone was to trip and fall, it would be able to withstand the fall. After implementing this test, after the third iteration, it did end up fracturing right at the fillets on our previous design. And so after adjusting and analyzing all that, I went ahead and told Shay to go ahead and make the design adjustments, and then created this overall design, which actually withstood the testing far greater.
Hi, my name is Aiden Gomez. I am part of the Good Shepherd, and my team, my role in this project was the team lead. So what I did was pretty much keep everything intact and making sure that we were up to schedule. And in addition to that, I was also in charge with operating and conducting multiple tests. One of the tests that I conducted was the power test, in which we would have to test how much amps is being drawn, basically how much current is being drawn from the device. And from that, I would document it using a table and weight different iterations to see how long the battery is consumed and the voltage drop over time. And with that, we were able to determine that a regular 7.2 amp hour battery can last for 48 hours for a device. So that's pretty good. And then, so yeah. I've also conducted the vibration test as well. That one I used we used a shaker table as shown in our poster. In the shaker table, we were able to mimic vibrations being occurred when it was mounted onto an ATV. We used that using a vibrometer, and basically like a little, like a cell phone app that we put inside our device, and we mimic those vibrations as it was going. So the vibrometer measured the acceleration of the device, either in the X and Y and Z coordinates. So we were able to get a good feel on what the device was acting at that point. So yeah, and I was also in charge of organizing and keeping in contact with institutions so that we can provide a field test as well. So I organized with different departments to ensure that we had animals to keep intact. In addition to that, I also did the Longhorn test for that as well. I also was in charge of creating the after action report. In that report, I basically explained what problems that we faced during the manufacturing process and ways that we came to solve them. So, like mentioned before, we these things, the phalanges sheared off, and so that we increased the thickness and therefore made it more durable. And we also increased, and other things occurred too that we had problems with, especially with sharp edges. We made them smoother, and it's more compact and very easy to use.